To evaluate a composite function, I'm going to begin with the x value they've given me in parentheses. So in this first example, my x, my input is 1. I'm going to begin by plugging that value into the g function, the function closest to it. So taking a look up here, I'm going to plug in 1 for x and evaluate. So I've got 4 times x, or 4 times 1, which equals 4. Now, that's not my final answer. What I'm going to do with this, using function composition, is now take that 4 as my x value, and now plug it into the f function. So the f function is 2 times 4 squared minus 3. And then evaluate this. Following order of operations, I do exponents first, so 2 times 16 minus 3, which would be 32 minus 3, or a final answer of 29. And these next examples are no different. Notice this time I've switched the order. I'm doing g composed with f. I'm still using an input value of 1. I want to see if this makes a difference if I do this in a different order. So I'm going to take 1 as my x value, and this time start by plugging it into the f function. Always start with the function closest. So I'm going to evaluate 2 times 1 squared minus 3. Doing exponents first, I know that's 1 squared, which is still 1. 1 times 2 is 2, and then 2 minus 3 gets me a negative 1. And again, just like last time, I'm going to take this as my new input value and plug this now into the g function. I can see that I'm going to, yes, get a very different answer. So to finish this one then, 4 times negative 1 gets me a final answer of negative 4. So function composition, the order does matter. It's not commutative. I can't switch the order and just get the same answer. These last two examples will plug a function into itself, and that's weird, but just fine. So take negative 2 as your input, plug it into the f function. So I'd have 2 times negative 2 squared minus 3. When I square a negative number, I multiply it by itself, so it comes out even. So that's 2 times 4 minus 3, or 8 minus 3, which gets me 5. Well, just like the other examples, I'm now going to take that number and plug it into the second function. So plug 5 back into f and evaluate. And when I finish evaluating this, 5 squared is 25. 2 times 25 gets me 50. Subtract 3, so a final answer of 47. Are you getting the hang of it yet? We'll do one more example if you need to see this one more time. So once again, I'm going to take negative 1 as my input value. Start with the function closest to that, so plug it into the g function first. 4 times negative 1 is negative 4. That becomes the new x value, which we'll plug into the second function, which this time also happens to be g. 4 times negative 4 gets me a final answer of negative 16.